Okay, so far we've talked about thunderstorms, tornadoes, and hurricanes. Now these storms all have several things in common with one another. Can you think of what they'd be? Let's write some of the main similarities in your notes. First of all, they're all formed from a fast-moving cold front, meaning a large mass of cold air is moving quickly into a warm, moist mass of air. Next, these storms all have cumulonimbus clouds, or thunderheads, as the centerpiece of their storm mechanisms. Thirdly, they all have a convection current mechanism inside this cloud due to the massive updraft from the heat contained in either water or land. And lastly, they all need energy from the heat contained in some body of water in order to form and to keep formed. Okay, now let's move on to our last type of storm, one we are all too often familiar with, the winter storm. Because we live in a northern latitude, our climate is much colder than those nearer the equator. Now we've discovered that because of our unique climate, we rarely get the warm weather storms we just mentioned. Our weather is much less severe during the spring, summer, and fall months. That's not to say we don't get severe weather during those months, because we do. However, it doesn't happen nearly as frequently as the southern states. Now, we all know that winter storms are among nature's most impressive weather spectacles. The combination of heavy snow, freezing rain, and high winds can totally disrupt modern civilization like it did on the East Coast last week or this past week, closing down airports and roads, power outages, and downing telephone lines. Winter storms remind us how vulnerable we are to nature's awesome power. Write in your notes that winter storms derive their energy from the clash of two air masses with huge differences in temperature and moisture levels. Also write in your notes that in North America, winter storms usually form when a mass of cold, dry air, Canadian air, moves south and interacts with a warm, moist air moving north from the Gulf of Mexico. So if we look here now at the picture that we have here, this warm air would come now from the Gulf and be fed, be fed now this way. You can see that happening right here in this picture. And then it would clash now with this really, really cold air that's coming down from Canada. That is a recipe for a classic winter storm. Now we've learned that this point where two air masses meet is called a front. So you can see this massive front right here in this diagram. We've also learned that if cold air advances and pushes away the warm air, it forms a cold front, which you can see right here. And that when warm air advances, it rides up over the denser cold air mass to form a warm front. Write in your notes that if neither air mass advances, if neither of them advance, it forms what's called a stationary front. So if neither of these masses moves, there's a stationary front that forms right here. Stationary front. Also write in your notes that a winter storm is composed of three factors: cold air, moisture, and the lift that we see right here. So cold air, moisture, and the lift that we see here form basic winter storms. Now write that winter storms usually form along a stationary front, and that these fronts form when an area of lower pressure develops along the front as the atmosphere tries to even out the pressure difference. So you see a stationary front here. So again, cold air is trying to push this way, warm air won't let it, so it stalls now here along a stationary front. Now let's get the steps in the formation of a winter storm in your notes. First, write that the stationary front creates wind, which blows from high pressure towards low pressure in an attempt to move enough air to even out the pressure difference. Secondly, as the air moves toward the low pressure area, it's got nowhere to go but up into the coldest regions of the atmosphere. So this air now has no place to go because this front is stationary, so boom, right straight up. Thirdly, write that this causes water vapor in the air to condense, we already know that, and that to the north of the storm, where we're usually at, where temperatures are colder, this condensed water falls as snow. But to the south, if the temperatures were warm enough, it can fall as heavy rain or thunderstorms. So in latitudes above this, it would snow. In latitudes below this stationary front, rain, or some combination of rain, sleet. So let's write that the classic East Coast winter storm is called a nor'easter. You see it right here, a nor'easter. It gets its name from the direction the wind is coming from in the storm. Obviously, the wind comes in from the northeast in a nor'easter. Now, write in your notes that here in the Midwest, winter storms are often caused by something called an Alberta clipper. You see an Alberta clipper here on the right. Now, write that an Alberta clipper is an area of low pressure that generally forms over what Canadian province? Alberta, which is east of the Rocky Mountains. Now, also get in your notes that clippers develop east of the Rockies because air flowing eastward over the mountains creates favorable conditions like you see here in this diagram. Also write that over North America, strong winds blowing from west to east usually move a winter storm quickly across the continent. That's why a winter storm rarely lasts more than a day in one area. Okay, now let's move on to blizzards, not the ones you buy at Dairy Queen. We're talking about the weather blizzards. Write in your notes that the difference between a blizzard and a snowstorm is the strength of the wind, not the amount of snow. So that's a common misconception. To be a blizzard, a snowstorm must have sustained winds or frequent gusts that are greater than or equal to 35 miles an hour with blowing or drifting snow. This then reduces visibility and lasts for a prolonged period of time. Typically 3 hours or more would be labeled a blizzard. Also write that a ground blizzard, you see a ground blizzard right over here, a ground blizzard refers to a weather condition where loose snow or ice on the ground is lifted and blown by strong winds. So the primary difference between a ground blizzard and a regular blizzard, and in a ground blizzard, no new precipitation happens. It's just picking up precipitation that's already there. But the effects are the same. You get visibility, blowing snow, etc. It's just then at a blizzard, new snow happens. In a ground blizzard, there's no new precipitation. Okay, the last thing we want to talk about with regard to winter storms is lake effect snow. So write in your notes that lake effect snow is produced during cooler atmospheric conditions when cold winds move across long expanses of warmer lake water, warming the lower layer of air which picks up water vapor from the lake. So, in this picture now you see a classic lake effect snow. So you have this cold wind now that's moving across land. And remember, cold air has little moisture in it. Why? Because the molecules are so close together and so dense they can't contain much water at all. So here comes this extremely cold air mass moving across the land, and it encounters open water. Obviously, if it was ice, there would be no lake effect possibility. But because now, like last year it was so cold and the river froze and the Great Lakes froze that we got very little lake effect snow. But now if there's some open water like there is now, this cold wind now can blow over this warmer water, pick up the moisture now from the warm water. Obviously the temperature of this cold wind goes down a little. So if it goes down a little, it can suck up some of this water, and then boom, it rises back onto land, cold air squeezes it like a sponge, and now because it's cold air, that water then turns to snow, and we call that lake effect snow. Makes sense because the lake is actually what's driving the snow. And it's usually a completely different kind of snow as well. You could tell lake effect snow because it's really small crystals. At home we call it slow, sneaky snow, rather than the big, huge drops that are wet, that are typical of a front type of snow. So, write in your notes that the land cools much more rapidly than the water. In our case, the Great Lakes, more specifically, Lakes Huron and Superior, depending on where you live in the UP. However, get in your notes that any lake can produce lake effect snow. Now, also write that when a cold, dry air mass from central Canada moves down across one of the Great Lakes, it picks up water vapor and heat from that lake, and as soon as the air mass reaches the other side of the lake and hits land, the air mass rises, cools again, and the water vapor condenses and falls as snow. Now, as you know, we get all kinds of lake effect snow warnings during the winter. I really believe when that happens, our meteorologists are bored because there's really nothing happening front-wise. So let's, figure out where there's going to be lake effect snow and throw a warning out there. That's probably not what happens, but that's kind of my take on it. But what happens is that lake effect rarely happens. So write in your notes that the reason lake effect snow rarely happens here is because we need the wind to blow in such a specific direction in order for us to get lake effect. Write that in our case, it needs to be directly from the northeast because we get most of that lake effect snow from Lake Huron, or we can also get it from Lake Superior when the wind blows straight out of the northwest. So next time you see a lake effect snow warning, say pshaw to that, because it rarely happens, and now you know the rest of the story. Okay, that's it for this part 7. Take a picture of your notes, submit them to Moodle, go grab that study guide and answer the questions, and that does it for our podcast on storms. Our next topic will be oceans, and we'll get back to you when we start the ocean podcast. Bye.